Today, I'm going to talk to you guys about unsupervised learning. And I want to point out that all the examples and all the case studies that I'm going to show, we're all using H2O all the time. And just as I guess a brief overview, so in supervised learning, you're training an algorithm on a known set of outcomes. But in unsupervised learning, you're trying to learn the internal structure of your data set where there is no prediction required. So my favorite example is the iris data set. In 1939, I mean, some poor guy had to measure 150 iris flowers and take the petal length and the sepal width and do this whole measurement. And of course, data collection is a lot faster now, but the idea stands the same, which is supervised learning stands on curated data that requires prediction. Unsupervised learning, not so much. And so today, I'm going to purposely kind of stay away from a lot of the theory, so I promise you're not going to see a single formula from me the entire time. And instead, we're just going to jump into some really practical examples of how we use unsupervised learning to solve what I think are extremely important problems. First and foremost is single malt scotch. So about 2 years ago, I was given my first bottle of single malt scotch, and it was Tellez. And when I tried it, it was smoky, it was malty, tobacco-y, it was funky, it was all those things at once. And that kind of like blew my mind to think more about what is it that I'm drinking. And it turns out that a lot of amazing single malt scotches come from one particular region of Scotland, northern Scotland. And here there's just a few areas. There's Speyside, there's Islay, there's Island, there's Highland, there's all these other things. But basically, I was floored by all the amazing flavors of this single malt scotch. And so I thought, can I build my own recommendation engine to recommend single malt whiskeys to myself? Right? Because I know what I really like in these scotches, and I wonder if we can use unsupervised learning to recommend other whiskeys that I should be trying. So of course, I'm not the first guy to answer this question. There is in fact a single malt data set that's got 85 distilleries from Scotland. And for each one of the distilleries, there are 12 descriptors, and it goes from like, smoky, tobacco, it's honey. And each descriptor was rated, so 0 being it's weak or 4 being strong. And again, what we want to do is how can we use unsupervised learning to learn more about single malt scotches, but more importantly, contribute to my beverages and more club points, because since I've done this, I'm now a BevMo member and good things are coming my way in the mail. So what we're going to do is, I'm a big fan of combining multiple machine learning approaches. And for this study, we're basically going to do dimensionality reduction using principal component analysis. So we're going to take the 12 descriptors about our single malt, and then we're going to compress them using dimensionality reduction via PCA. So those 12 are going to now go to 7. And this newly transformed data set, which explains 85% of the variance, we're going to run k-means clustering. And then the output of that clustering, we're going to get the cluster assignments, and then I'm going to be able to say, I like this whiskey. What other whiskeys will I like that cluster well with those whiskeys? And so some of the results, so just to let you guys know, I tried Tellez, that was the first whiskey I tried. Then I really tried Speyburn, I really liked that, and I noticed that those two were all in the same cluster. And the idea is what other whiskeys cluster well with those two that I tried. And I'm a proud owner now of Cale Isla and Ardbeg whiskey as well. Some of you guys, one of the other big brands is Laphroaig. And so you can say, hey, I really like Laphroaig or Oban, and these other two cluster well with this whiskey. And before I get into the next example, I want you guys to know that when I showed Sri this the first time, he was so overwhelmed that he actually bought many of those whiskeys. And so for those of you guys staying after the whole function, you can go to the H2O headquarters, which is not far from here, and you can actually try the whiskeys. We'll have the data set up, and you can figure out what whiskeys you like that you can enjoy that you're not seeing. So that's just one application of machine learning to fuel my alcoholism. The other thing that I really like is ramen. And for those of you who don't know, it's basically Japanese noodles. What's there not to like? It's just noodles, broth, and beef. It's great. And the idea is if you were going to go out to ramen noodles tonight here in Mountain View, where would you want to go? And so what we did is we went on Yelp, of course, and we harvested our own data set, which returns all the ramen shops around Mountain View. Now, this is not big data. I'm not talking like 1.5 billion rows here. I'm talking 66 ramen shops around Mountain View. But each one of those ramen shops returns some features about it using Yelp, right? It says like, what's the star rating? How much does it cost? How many photos are on there, et cetera, et cetera, et cetera. And what we're going to do is we're just going to do the same analysis that we did with our whiskey data set. We're going to reduce the dimensions and then cluster it. And so just to let you guys know, I mean, I have on here Shalala, because when we came out here to visit H2O, we were taken to Shalala. And I really like it. They do pretty good ramen, so let's see what we can do. So at first blush, we take all of the features in our ramen data set, and it turns out that two principal components explain 85% of the variance in our data set, and that's this nice graph here. And I've pinpointed where Shalala is right there. And the really nice thing about this graph is we're going to run clustering on this graph. And then from that clustering, we'll be able to do the same thing we did with the whiskeys and basically say, what ramen shop should I be eating at dinner tonight? And so as a result, you know, we come up with this nice little thing which says, you know, hey, I really like Shalala ramen. And using the grid search tool in H2O, there are 4 unique clusters of restaurants based on this graph. And you know, for dinner, there's a good chance I'll probably be at Ramen Parlor tonight. And you know, I'll let you know how the algorithm works. And so, you know, this one's really simple. That's just dimensionality reduction. That's k-means. And principal component analysis is linear transformation. But what you guys really want to know is nonlinear transformation. Now we're going to be in the world of neural networks and in particular autoencoders. And so, you know, as with the other examples, I'm a big example guy. So, you know, aside from whiskey, I've also gotten into wine, all the expensive habits. And there's a region in France, the Bordeaux region, and aside from being the 6th largest city in France, they are also the biggest and the largest wine growing region in France. So they produce Bordeaux Reds, which we typically know, but they also produce white grape varietals, and it's called Sauternes. And it turns out that some years in Bordeaux are really, really outstanding compared to the other years. And the price differential for those bottles that are outstanding versus not outstanding are huge. So take a high quality producer in Bordeaux, and on a non-great year, you're talking about $500 for that bottle of red wine. But for a vintage year, a great vintage year where the weather lined up, the winemaking process was perfect, that same bottle from a high quality producer can run you like $3,000. So huge difference in price just for wine coming from the same chateau, because there's a lot of these houses that are storied that make this wine. And what's really interesting about buying Bordeaux wine is there's a futures market for it. You can actually buy it on Premier. And what that means is as soon as the grapes are harvested and the winemaking begins, it's actually a 3-year time period where the wine has to be barreled and then it gets bottled, and then people like you and I, we can go to the beverages and more and go buy the wine bottle. But before that point takes place, a whole bunch of I think they're wine geeks, but basically a whole bunch of wine testers, they come in and they'll try the wine while it's still barreled. And if the judges go, okay, this is going to be an amazing wine this year, then when the wine is bottled, the price for the wine is already set. So when it hits the floors of Bevmo, it's already at a ridiculous price that you and I can't buy. And so, you know, there's an entire futures market for Bordeaux wine. And the idea is if these people, if like wine merchants and wine distributors can know if the wine is going to be good before it's bottled, they can make an investment in the wine at that point. And then once it hits the shelves, they can cash in on their investment because the wine's price will already have been fixed before then. And so what you're looking at here is a graph of the average price per bottle over time. And notice that I'm calling out to 3 years in particular. There's 2000, 2005, and 2009. Those years were outstanding vintage years. So this is when, you know, across the board, all these wine geeks were saying, this wine is 100 points. Buy this wine, it's incredible. And as a result of that, the average price for these wines has gone up a huge amount, and the demand has risen incredibly. And so I know what you're thinking, where am I going with all this? And before I tell you where I'm going with all this in the world of neural nets, I wanted to play for you guys just a really quick trailer of the idea that spurned this whole next few slides that we're going to do. Is there sound? Sorry.
When I came here and they told me these are the best pieces of land, I thought, sure, but it's true. It's perfection.
To make a great wine, it's not only a great terroir, a great chateau, but then it's the human factor. You know, you need love.
It's more than a manufactured agricultural product. It's something closer to a miracle.
The resilience of Bordeaux is quite amazing when you realize that this place has been able to survive revolutions, wars.
Things can change in both directions. What we must protect is the wine.
Right now, I think everyone has the wine fever.
You have seen demand massively exceed supply.
Today, China's probably got around 600 US dollar billionaires. That's more than the US.
America used to be the biggest market in the world for these wines, and it's not anymore. The prices are just too high.
No matter what, this is what I want. I want to bring it home. The auctioneer was going like 300,000, 500,000. Then suddenly, I just raised my price.
If they've lived through the Cultural Revolution, this means they've gone to hell and come back.
If a dozen mainland Chinese decided to buy everything in the marketplace, very soon it only takes a few people to corner the entire market.
Okay, so hope you guys kind of got a feeler for just how popular Bordeaux wines are. And they're incredibly high in demand, especially for those vintage years. And so what we thought of was, what if there was a way we can study the weather patterns in Bordeaux leading up to the harvest, and then kind of come up with our own prediction of saying, like, this is going to be a great vintage year versus a typical vintage year in Bordeaux. And so we kind of, we're saying that a great vintage year is going to be an anomalous data set. And so you can see where I'm going with this. We're going to train an autoencoder, which is going to learn what the typical weather pattern is like for a non-great vintage year of Bordeaux. And then we're going to feed it some newer data, some of which has those vintage years, and fingers crossed that those vintage years show up as anomalous years with respect to the weather. Now, obviously, wine is more complicated than just the weather, but that's what we're going for. So what we did is we built our own data set. We became like part-time meteorologists in the process, where we went from 1952 all the way to 2014, and we're looking at very, very simple things. We're looking at the amount of rain that's coming in the winter, because that, of course, sets up a healthy vine. We're looking at the summer temperature, because if it's too hot, then the vine can raisin, and then you're getting too much sugar in the grapes, also not good. And then we're looking at the amount of rain coming in the harvest, because you don't want a lot of rain coming in the harvest. You want sunshine so that the grapes can photosynthesize, so that the grape is ripe at the time of picking. And then we're looking at the number of years since the last great vintage. And as you said, each one of these years, they're not happening every single year. So great vintages do not happen every year. They're extremely rare, but when they do happen, they are financially huge. So in steps, what we're going to do is we're going to train an autoencoder to model the typical vintage year weather patterns up until like 1990. And then we're going to throw in this brand new data set of 1990 all the way to 2014. And some of that has the vintage years. It's got the years in which everything was lined up perfectly and the wines were rated 100. And what we're hoping for is that our autoencoder will have a difficult time in reproducing the great vintage year data, and it will have a high error in reproducing it. That error will denote it's an anomaly. It'll show up, you'll see it in a second, and we can say, oh, that's really interesting. Those great vintage years with respect to the weather are anomalous. And so what we're getting at with the last point is we're trying to get on premier of on premier. And so we're trying to beat the wine snobs at their own game and see if we can do better than when these guys come in and taste it. So the results are kind of interesting. So what I'm showing here is we're showing the results of our autoencoder, and this orange line represents a mean squared error of 0.25. So every single data point that it has a higher mean square error than 0.25, I have labeled with the vintage year on it. And it turns out that of the 9 points that show up as anomalous years with respect to the mean square error, 7 of the 9 are vintage years. And the 2 that aren't, 2003 and 2011, it turns out that those wines from that year, because Bordeaux is so big, the Sauterne and the right bank, which is some of the subregions of Bordeaux, they produced outstanding wines. But the left bank was not as good as the right bank, so the wine scores were inconsistent. But it still picked up the fact that some of those wines were better than the other. And so I know what you're thinking now. You're thinking, well, if this thing works, should I invest in the 2014 vintage, right? Because what you want to know is, like, should I put my money on this? And it turns out that when we look at 2013, and we know how it happened with 2013, it was not a good year for Bordeaux. But if you buy this anomaly detector, then 2014, based on the weather that we're seeing in Bordeaux, is not one in which we should go to Beverages and More and start stocking up. So, just to let you guys know that's all I had for this. But on our GitHub, we have the original single malt data set. We even have the GitHub that shows how you do it in H2O and R and using the GUI. And I'd love for you guys to join me at H2O, where I'll be drinking some of those single malts that we recommend here. And I will tell you personally that it works, because I'll be drinking those ones that I like. And with that, I'll take some questions if you got them. Yeah.
So I'll come around with the mic for you.
So I have a question about some of the different clustering methodologies.
Yep.
What do you have implemented in H2O right now, and are there any other clustering algorithms you're looking to implement in the near future?
So I should point out that I don't actually work at H2O, but the only ones that are in there currently as far as clustering are k-means. So if you're asking if, other things like hierarchical clustering, I don't think that's there now, but for this one, we use the standard k-means, which is your junior varsity clustering algorithm,
Mm-hmm. And do you have any opinions on k-means versus the hierarchical clustering, or most of the time k-means seems to work well in your data sets?
Well, the reason why I like k-means is because I can explain it to my managers a lot easier, whereas the other way, it's a bit more complicated.
Okay, thank you.
Yeah.
Hey, my question was, given that you've now had a chance to look at these different kinds of data sets, any experience where, or any situation where you had to do feature engineering with any of these examples and how you went about doing that, that would be interesting. Like if some certain obvious features, certain features were not obvious earlier, but then were obvious later, or some math that you had to do to get some new features associated to solve some of the problems.
Yeah, so the question was, do we have to do some feature engineering to get at, let's say, the Bordeaux data set? And for that one, we probably should have done more, but it's because we're not winemakers that we didn't actually know what to do. We kind of left it up to the algorithm, because remember, the autoencoder, it's creating those features that you would have to do feature detection for, and we're specifying in H2O, here are the number of hidden neurons or deep features to look for. But we probably should have, we can definitely do more feature detectors. I'm more than happy to do feature detectoring on whiskey with you later.
So you mentioned that you used a deep autoencoder. So how many layers did you use?
So for the autoencoder right now, so in H2O, there's only one layer because they don't have the stacked autoencoder model yet. But we took the 4 features that we had, which are rain, sunshine, and days since the last great vintage, and we compressed that representation to 2 deep features. And then those 2 deep features learn the pattern of non-great vintage year weather data, and that's how they did their anomaly detector. Any other questions? All right, well, thanks. Oh, one more.
Can you go back a couple slides to the...
Yep. Sorry?
Yeah, that one. How did you pick the cutoff, the threshold of 0.25?
Yeah, so that threshold is pretty much determined by us. And so you want to figure out something that is far enough out there that, to you that looks like an outlier. But we kind of picked that cutoff arbitrarily, and that was our decision.
Did you factor in any other data other than the weather?
No. So, like a lot of these vineyards, they have like special soil and the vines are planted on the southerly slope. I don't know that data at all. So all I did was harvest a whole bunch of weather data to come up with our data set. Mm. All right, thanks so much, guys.